Hello everyone, welcome to my channel. And from this is going to be a series of videos on where we develop we where I'm going to be developing a chess app mainly for Android or iOS, so basically for mobile devices. So this chess app is going to be fairly complex, more so than the tutorials already available on YouTube. Because later down the line, I want to develop a AI so which you can play against, and if these videos get a lot of likes and views, then I will make a tutorial on how to do that. If that sounds like something you'd like to do, then let's jump right into it. So over here you can see that I have a new Unity project opened up. This is just the layout I'm working on, and this is a 2D project. And only the only settings I've changed is I clicked on Android and I switched the platform. So if I click on iOS right now, and you can see that a switch platform button appears on that. So that's the thing I did for Android. So without wasting any more time, let's start. So the first thing I want you to do is create a new empty game object and call it the chess board. This game object is going to have most of our scripts attached to it, which are going to contain the logic for the chessboard. In this video, mainly what we're going to do is we're going to be focused on setting up the chessboard and making it appear on the screen. So what we want a new C# script, and I'm going to call it board UI because it's going to contain the logic and the code for most of the UI elements of the game. So the chessboard, the highlighting of the different squares of the chessboard, and so on. So let's open this up in VS Code, and let me get rid of all this. The only thing we need is mono behavior because it is going to be Unity. It is a Unity inbuilt class, and we are going to need it for this code. So we need the awake function, private void awake, and inside the awake function I'm going to I'm going to call a generate board function, which is going to take care of all the logic for us for setting up the entire board. So generate board, and let us just declare this function right beneath it, private void generate board. So what this function is going to take as input is the square count. So this is the number of squares on each side of the board. So since we are playing chess, it's going to be 8 by 8, 8 squares by 8 squares, and the square size, because the program needs to know how big each square of the chessboard is going to be. So you might be wondering why square count is an int while square size is a float, and you might say that no, I want my square size variable to be an int. So it won't work like that because each user, when we publish the app on the Play Store, each user is going to have a different size screen for the device, and depending on the size of the device screen, we want the chessboard to be of different sizes. If it's a bigger screen, then we want a bigger chessboard to appear on the screen, and if it's a smaller screen, then we don't want the chessboard to not be visible because it's so large. So because of that, it is going to be processed at runtime and not pre-processed. So let's just fix so let's get working on that. So square count is going to be a constant int, and I like to name all my constants in capital letters. Its value is going to be 8 because, as I mentioned earlier, a chessboard 8 by 8. And as for the square size, it's going to be a static, oh pardon me, it is going to be a static float square size. Yeah. And now, what is going to be the value of square size? We know that square count is equal to 8, but what is going to be the value of square size? So I'm going to declare the value of square size in the awake function itself, and Before I explain why it is the way it is, let me just write down the line of code and then I'll break it down to make it easy to understand. So square size is equal to 2 times camera dot mean dot orthographic size into screen dot width divided by screen dot height divided by square count. So this might seem like a lot to take in, but let me just break it down to make it simpler. Camera dot main dot orthographic size is is half the size of the viewing screen available. 2 times of that is the full screen, is the size of the full screen, height of the full screen. Screen dot width divided by screen dot height is going to be the ratio of width by height of the screen, and we are dividing it by square count because we want the size of the individual square, not the entire length of the chessboard. So if we imagine that this is my mobile screen and the chessboard is going to appear on the center of this screen, then the width of the chessboard is going to be equal to the width of the screen size, which is going to be equal to the height of the chessboard, because surprise surprise, a chessboard is a squared in shape. So that is why we have the logic for that. And let me just fill in the input values for the for the generate board function. Square size. Okay, so the way the generate board function is going to work is it's going to call a generate square function, which is going to take care of all the logic for generating a single square, and we are going to call that 64 times. So some of you experienced coders out there might already have a way to do this, and for that we are going to be using a for loop. The first loop invariant is going to be called a file, because in chess notation we call the row is square in the rows as files and is square in the columns as ranks. So the next is going to be rank equal to 0, rank less than square count, and rank plus plus. So pardon me for just a second. Yeah. So inside the generate board function, we need two more things: the generate square function, and the generate square function is going to take the file of the square, the rank of the square, and the color of the square. So to get the color of the square, we have to store it in a variable, and for that I'm going to declare a new variable called as square color, and we're going to get the square color by declaring another new function, get square color. And what this function is going to have is the references to the square colors, the materials, and the file and rank of the square. So int file, int rank, pardon me, it doesn't need the type for the variable, rank, and square colors 0 and square colors 1. So you might be wondering what this square color 0 and square color 1 is. So this is a variable that we have to declare, and we are going to add the materials from the Unity editor, and we are going to link them to this C# script. And the way we do that is this: serialize field private material, and this is going to be an array of materials, and we are going to be calling it square colors. Okay, so this is an error because we haven't actually declared the function yet, and after that we are going to call the generate square function, but we don't have anything to store the squares which the function is going to spit out. So we have to declare one more field, and that is going to be private mesh renderer, and it is going to be a 2D array of mesh renderers, and I'm just going to call it squares. So this is a 2D array because it is easier to work with the x and y indices like we do in other games. So that is the reason for that. And we are going to store the squares generated by the function in this 2D array, generate square. Now the generate square function, what it's going to take is the square color, the square size, the file, and rank. So square color, square size, the file, and the rank. So now we have to make these functions. So for that, first of all, I'm going to declare the get square color function. So this function is going to be public because it is going to be accessed by a lot of other classes later down the line. So public material get square color, and this function is going to take the file, the rank, and it's going to take in two colors. I like to call them light square color and dark square color. So the logic for this function is fairly simple. The way it works is, first we have to declare a bool, and we check if the square is a light square or a dark square. The way we do that is we add the files and ranks, we take the modulo 2, and if there is a remainder, then this value will evaluate to true, and then the square is going to be a light square color. But if it's not, the remainder is not 0, then it's going to be a dark square color. So for that, so we already have that. Now we just need to set the material, and that material is going to be material square color is equal to is light square color, dark square color. So this is the ternary operator in C#. It checks if this boolean statement evaluates to true. If it does evaluate to true, then the value of square color is going to be light square color, otherwise it's going to be dark square color, and then we're just going to return square color. So this is the get square color function done. Now we have to declare the generate square function. So this is going to be a private function. It's going to return a game object, generate square, and it's going to take in material, which is going to be the square color, the square size, the file, and the rank. So first things first, we need a new game object, and we're just going to call it a square. Now Unity gives us an inbuilt function called GameObject.createPrimitive, and we need a square. A square is a quad, so the primitive type is going to be a quad. So this is an inbuilt function which Unity gives us to create primitive shapes in Unity. So this works really well for us. Another thing we want to do is set the parent of the transform as the chessboard game object that we have just created in the Unity editor, which this script is going to be attached to. Then we want to set the position of the transform to the center of the square. We're going to get the center of the square using the file and rank of the square, and to help us with that, we're going to create a new function which is going to be called get square center, which is going to take the file and rank as the input. we will declare this function later on. Now we've set the parent, we've set the position. Now we have to set the color. So square dot get component mesh renderer dot material is equal to square color. So we have set the parent, we've set the position, we've set the material, and yeah, I guess that's it. Now we just have to declare the get square center, and it is also going to be a public function. It's going to be a vector2 get square center, and it's just going to take the file and the rank as the input. And what this is going to return is a new vector2 Yeah, sorry about that, guys. I accidentally paused my recording and I had no idea because of the hotkeys I've set up in my recording software. So, let me just go through the things you might have missed. So, in the get square center function, this is going to be the logic we're going to be using. So, the way this works is we have a new vector2 of the file and ranks, and we're going to be multiplying that by the square size. We are multiplying it by the square size because uh, so imagine we have a grid of say 10 squares, and we want to locate the position of the center of, let's say, the sixth square from the x-axis, and the second square on the y-axis, so 6 comma 2. So that is going to be 6 comma 2 multiplied by the size of each square. Ignore the bounds part for now, and then we add half the size of the next square in both the axes, so we arrive at the center point of that square. The bounds variable is just the bounds of the chessboard. It's just to make sure that we are not going off bounds in any direction whatsoever. So this is the logic we are following for the get square center function. One more thing that we might have missed is this line of code over here. Square.transform.local scale is equal to vector3.1 into square size, just to make sure that each square is of the perfect size, which we have declared earlier over here. And we have declared two more variables, which is the bounds variable and the z offset. The bounds variable is just a new vector3 of square count into half the square size. So these are going to be the bounds, and we need one more, which is a private vector3, the board center, which is going to be equal to vector3 dot 0. So this is just the center of the board, and in case we need to pivot it to any other position later down, then we have the option to do so. And we want to add this over here, board center. So, oh my bad, not over here, we want to add this over here, board center. So yeah, so I think that is most of the logic covered up. Now we can go back to the Unity editor. We'll wait till this compiles everything, and now we just have to make sure that we attach the script to the chessboard game object that we have declared. And we need two colors, one for the light squares and one for the dark squares. So I'm going this is going to be of type unlit and color. I'm going to duplicate this, and let's call this one light, let's call this one dark, respectively. And let me just change the colors to something like this for the dark, and something a little bit off so that it doesn't hurt the eyes. Yeah, so these are the square colors. Let me make sure that okay, so we haven't attached them yet. I'm going to attach the dark material, if I can, to element 0 and a light material to element 1, and it doesn't want to. Okay, so now it's working. Let me just save and let's try to run this code and just make sure that everything is working. And we get an error at line number 29. Squares, what is the error? Null reference exception or object let's try to debug this. Okay, I think I found the issue. We have not initialized the squares 2D array. So we can do that over here. Squares is equal to new mesh renderer, and this is going to be of size square count comma square count, because again a chessboard is 8 by 8, and I think that should fix the issue. So now if we try and run this again, it should hopefully work. And it is working, but the chessboard is not in the center, so we might have messed up here somewhere. Bounds is 110, board center Z offset, and so let me try and debug this, and I'll see you guys when I figure out the problem. So guys, I'm back. I figured out the problem. It's quite simple actually. Over here in line number 18, you can see that we are using the square size variable before it is actually being initialized. So what we have to do is just move it to the top of the awake function, and that should hopefully fix the problem. Now if we try and run this code, yeah, it does work perfectly. So this is going to be it for this video. In the next video, we are going to be spawning actual chess pieces on the chessboard, and we might also end up having some user input to move them around the chessboard. So stay tuned for that, and I'll see you guys in the next one. Peace.